So we want to find the derivative of this function. We have y equal ln x over x squared, and we see that that is a quotient. Now, when I do the natural log, I'm going to get a fraction, and then when I do the quotient rule, I'll get a fraction. So I'm going to end up with a complex fraction if I do the quotient rule. So I'm actually going to pull one of the tricks of the trade, which is I am going to move this x up and express it as a negative exponent, ln x, and then when I do the derivative I have a product, and I think that's going to be a little easier to work with. So taking the derivative, I've got the product rule. First times the derivative of the second, and the derivative of natural log of x is 1 over x, plus the second, which was the natural log of x, times the derivative of the first, and that's the power rule. Power out in front, decrease the power by 1. So now I'm going to express this without negative exponents. And so I will move this down to the bottom and get multiplied to that x that's already down there, so it's going to become an x cubed, because this will be an x squared on the bottom multiplied by the x. And then here we have minus 2 ln x for the numerator, and bringing this down we have an x cubed in the denominator as well. So we might as well express this. I'm going to move up to do this as 1 minus 2 natural log of x over x cubed. Looking at our second function here, we'd like the derivative of the natural log of x plus 1 over the square root of x minus 2. And this is a composite function because we have the ln of some stuff, so basically ln u here. And so that's going to be the derivative of ln u is 1 over u du. So essentially we need 1 over the stuff. Now the stuff is x plus 1 over square root of x minus 2. So I'll go ahead and write it like this, and then we can flip it over here. But then we need to multiply that by the derivative of the stuff. Now, taking the derivative here, I think I'm ready to again pull the little trick of this is x plus 1, and I could express this as x minus 2 to the negative 1/2. And I think I want to do that because I've already kind of got a complex thing going on here, and rather than have this quotient rule with this radical and so forth, I would just go ahead and express this using a product rule. So this is going to be first, which is x plus 1, times the derivative of the second. I can see already that I don't want that parenthesis that close, so let's take that out. The derivative of this will be the power out in front, decrease the power by 1, multiplied by the derivative of what's inside. Don't forget the chain rule, however the derivative of what's inside here is a 1, so we could have gotten away with that. Okay, so we were doing a product rule. First times the derivative of the second, plus the second, which is x minus 2 to the minus 1/2, times the derivative of the first, but the derivative of the first is 1. So there we go. Let's see what we've got here. I can flip this over, so we'll put it another color since we've got a lot of stuff going on here. This is square root of x minus 2 over x plus 1, and then that's multiplied by looking to see what we have here. I've got a negative, and it looks like the x plus 1 is in the numerator, and in the denominator we have 2 and x minus 2 to the 3/2, and then plus 1 over x minus 2 to the 1/2 here. Now let's go ahead and distribute this through, and when we multiply this to this first one, our x plus 1's will cancel, and I'm going to have negative 1 over, if I bring this down, this is x minus 2 to the 1/2 down in the denominator would be minus 1/2, and so that would combine here. 3/2 minus 1/2 is 2/2 or 1, so that would just leave x minus 2. And then multiplying this to this next term, I see that this square root of x minus 2 is going to cancel with the 1 in the denominator, and so that's just going to leave us 1 over x plus 1. So there's our derivative. That looks a lot better. Now let's go ahead and look at the graph of this function and its derivative. So we have Here is the graph of our ln x plus 1 over square root of x minus 2. And then here is the graph of our derivative, because we can see that this is a very large value negative slope approaching an asymptote here, coming down, and then we have positive but just a small positive number. So here is our derivative very negative coming up to 0, and then positive but very small.